This is the pH Phun lab, which goes with Lesson 20 in your Friendly Chemistry course. In Lesson 20, you will be introducing your students to the concepts of physical change and chemical change. In this lab, your students will have many opportunities to witness chemical changes, evidenced primarily through color changes. In addition to witnessing these color changes, your students will also be exposed to the concepts of pH. In this lab, you'll need to prepare a pH indicator solution. The solution we have here is the juice made from cooking a red cabbage. To prepare the red cabbage juice, you'll first need to take your cabbage and chop it, then place it in a saucepan with some water and bring it to a boil. After it boils for 10 to 15 minutes, turn off the heat and then allow the juice to cool. Once cool, you can pour it off into jars or other containers and have it ready for your students. Note that if you keep it overnight, you'll probably want to refrigerate it. It does develop quite an odor over time. Another source for a pH indicator is purple grape juice. Grape juice works equally as well as giving you color changes in the presence of either acidic or basic substances. And yet another pH indicator that works well is the juice made from crushed blueberries. Now these blueberries can either be fresh blueberries or frozen berries. What you'll do there is just mash up some of the berries, add some water to them, and you will have an adequate pH indicator. Let's look at the data table your students have in their books before we go on here with the demonstration. Note that in the first column, your students will list the test solution that you've given to them. We suggest that you provide them with a variety of test solutions, both from the acidic and basic end of the pH scale. A basic substance that's easy to use with your students is baking soda. Another basic substance is baking powder, which is actually a combination of baking soda and cream of tartar. Ammonia, used in cleaning, is a basic substance. On the other end of the scale, vinegar is an acid. The fancy name for vinegar is in fact acetic acid, and so it's definitely on the acid end of the scale. Any sort of juice, orange juice, lemon juice, basically anything that's considered sour is usually an acid. So to begin the lab with your students, what you'll want to do first is to provide some of the pH indicator solution for them. And it's a good idea to go ahead and label that container. So we'll just label here that this is pH, and I'm just going to put pH indicator here for your students. If we go back to the data table here, your students will first write down the name or identification of the solution that they will be testing. Let's pretend that we're going to use the vinegar as our first test solution. And so what you'll want to do is provide for your students containers that will hold the test solutions, these unknown pH solutions. So in this first cup, it's a good idea to go ahead and label it. So we'll just label this vinegar. This comes in handy later when your students want to compare color changes. So we'll identify this one as vinegar, and then what you'll do then is provide your students with samples of the vinegar. You'll go around the classroom and give each one a sample of the vinegar in their cup. The next thing what you'll want to do is show your students how to go about transferring the indicator solution to the test solution. So in this cup, your students will have the grape juice or the cabbage juice that they're testing. If you have access to droppers or small pipettes, that's ideal. Something that's a little easier to come by are soda straws. And what I've done is I've just taken some straws and cut them in half to make them a little easier to handle. What you'll do then is just dip the straw down into the juice, come up with a sample, and then you'll transfer that over to your solution of unknown pH and then just drop it in. You want your students to know that you don't want to contaminate this your indicator solution with anything. So once they bring the juice over to the unknown solution, they need to just let it fall in. Don't put it down into the solution and doing any stirring, because when they go back, they'll contaminate their indicator solution. Okay, so the straws that go in the indicator solution will be the ones that stay there and just transfer the indicator solution out. So if we go back to the data table once again, they'll list that the identity of the solution, then they'll note the initial color, so the color when you brought it to them, what it looked like, and then the color after adding the cabbage juice or grape juice or blueberry juice, whichever you've chosen to use. So what the color change is right there. Now I'll go ahead and tell you, with any substance that's an acid, like the vinegar that we're using here in our example, an acidic substance, acidic, so it's an acid substance, the sour substances, the purple cabbage juice will turn a pink color. They'll definitely see an immediate color change. It will be a pink color, reddish to pink color change. The stronger the acid, the more pink the change will be. With basic substances like your baking soda, your baking powder, ammonia, those substances will turn the purple cabbage juice a green color. So bases will turn it green and acids will turn it pink. So on their data table here, there's a column that says is it an acid, is it base, or is it neutral. So if it turns pink, they'll write in acid. If it turns green, they'll write in its basic. If they see no color change, they can either put neutral. The substance itself may actually be acidic or basic if you tested it, say with some litmus paper or some hydrion strips, but yet it's not apparent enough with our indicator solution here. So this is not a absolute indicator for your students here. And then there's a column for any additional observations, anything else they happen to see with that particular unknown solution that they've tested. When you do start with a powdered substance, just mix it with some tap water or distilled water if you have it handy. Would be ideal. Just mix up a solution like for the baking soda, for example. Just take a couple of teaspoons, mix it into a container of water, and then deliver that out to your students to test with their indicator solution. Again, this is the pH Fun Lab. Your students will have witnessed many color changes as well as learned about pH.